Okay, then here's what I've got for you. So this is the sort of close-up footage and the quick recap. So we're going to run at proper pace here of sub alignment. So why would you want to do it? Well, if you've got your subwoofers on the ground and your main PA system up in the air, in this room, this is what we've got. We've got a point source speaker over there, Y7P, and obviously we're just working with what space we've got in this room. But we've actually created quite a distance between the subs and the what we could call the flown system, right? It's a speaker and a tripod in this case, but essentially what we're recreating here is distance difference between sub on the ground and the handover area, which is somewhere between sort of 90 hertz and 110 hertz, but we'll see that on the crossover in Smart. So that handover area in frequency has a arrival difference in time, i.e., if you are where the measurement microphone is, which is just around this corner, you can see the foot of it, and now here's a close-up of that measurement microphone. So the measurement microphone, i.e. the person at the barrier, front barrier of the gig, is much closer to the subs on the ground than they would be the flown PA system. So the only thing you've kind of got to imagine here, bit different, the geography in a real gig, because the flown PA system is up in the air above the sub. Obviously I can't do that in this room, but it will be up there. But rather than being up there, it's over there. But the thing is, it's about the difference distance, okay? So in terms of that difference distance, first of all, you should get an approximate of how far away the flown system is to you relative to the sub. Here's how you do it. So what you do is you get your measuring stick. This is a laser measure. It's the Leica. This is an expensive version, but you can get laser measures from like hardware stores for like 20 quid, something like that, 30 quid. This one has a camera, so it'll do outside, and also it does really long quite long distances. I think I've measured certainly like 130 meters, something like that with it. Anyway, the point is you've got to get a ballpark first, right? So you want to. It's all about the difference in distance. In that sense, it's similar to time alignment, but we're actually going finer here with the detail. The answer's all the same. There's a difference distance, and you apply a time delay so that you get two sound sources coming at you as one. The same is true of time alignment, but in this case specifically, we're going to look at what 100 hertz is doing, or around 100 hertz, because you can phase align around a key frequency. So we can actually get into a bit of detail here. Phase alignment around a key frequency in the heart of the crossover region between the subs and the main PA. But frankly, it boils down to this. Subs nearer to me, if I'm stood at the front barrier, than is the main PA system, which is up in the air in real life. And often, sometimes a bit further back as well. Actually, sometimes it can be further forward than the subs. It depends on the layout of the venue. But the point is, if subs are on the ground and the main system is in the air, there is a difference distance. Okay, so you can get your laser measure. Now, I'm going to stand around the corner, right? The measurement mic is just round this corner, okay? So I'm going to stand where the measurement mic is, or approximately, just so you can sort of still see me. I'm here, right? I'm going to get a ping off the main system, and then I'm going to get a ping off the subwoofer. And it's going to measure two things. I just sort of wasn't quite at the measurement microphone. I just wanted to show you what I was doing. Now I'm going to do it at the measurement microphone. I'm actually going to take my time to put it right on the capsule. Yeah, really close on the capsule, and just pivot it like that. So it's not going to be millimetre perfect, but it's going to be close enough to get a really good ballpark of what the difference distance is. Then I can convert that to milliseconds and check that what I'm seeing in Smart actually makes sense. I'll tell you the answer in just a moment. My bin's overflowing. Okay, so here's the answer. How well is that coming up on screen? I'll read it out then. So what we've got is, first measurement was 1.19 meters. Let's just call it 1 meter, right, for now. It's 1.19 though. We can just deal even with that meter. And then this other measurement is 5.7 meters. So 5.7 minus 1, or 1.1 if you're fussy. So 4.6. There's a difference distance of 4.6 meters. What does that equate to in milliseconds? Look how good's that. There's an app that tells you, well, this is that spreadsheet that's on Moodle. Search for really useful acoustic spreadsheet, or there's a spreadsheet. I think it's on week 1. You've all seen this if you've attended class, and it's really great. So it's told us it's got 13.4 milliseconds of distance difference between the subs and the main. Now let's take a look at what we do in Smart. Okay, so we're using the same show file that we've been using for the past few weeks on the SQ console. You've got that, so you can open that in SQ Mixpad. There's that, and Smart is set up as well. Using the exact same transfer function setup that we've got on Moodle and we've been using in the past few weeks. So here's what's going to happen. I'm just going to quickly test my system first of all. So in order to do that, I am going to go to Smart. I'm going to switch on some pink noise. Okay, so signal generator on in Smart. And then, well, I'll tell you what, I'll just do the full thing. So I'll just go to, bring this up to, oh, it's crashed. Bring it up to 0. And go signal generator, check where it's coming out, SQ audio, okay, great. I can see a signal on the console. I'm going to go, if I go minus 12 down, that'll be line level on the console. Let's have a look on the console, see what we've got going on. So we've got some signal there. So will you be able to make out the labels? Just about. Reference pink coming onto the desk. And I'll just lock the camera off there. And what we'll do is fade the main left and right up. And then we'll feed in the main system. I'm just checking the D20 amplifiers down here. I'm checking that there's a green light on it. And there is, so I'm going to fade that down. I'm going to unmute the PA system. I'm going to fade this back up again. Yeah, got that. I'm going to mute that, and then I'm going to fade the, sorry, this is the sub here. Can you see that? You can't quite make out the name, but that matrix is the sub. Check the show file in Mixpad. I'm going to fade that up. I'm checking I've got signal down here in the sub channel. I'm not going to unmute just yet, could be loud. And I'm going to unmute the sub. Okay, so I can hear both parts of the system. So that's system verification. Make sure you do that. Do the basics. And then next up, we can do what we do in Smart. So measurement microphone all set up, ready to go. Here's the on the board. It's this channel here, and I can see some signal. Signal should be reasonably well optimized based on last time. I'll show you what I've got going on Smart. So there we go. We can bring up the meters as well. So we go view and input meters. There they are. Oh, we've got some major level there with reference pink, haven't we? So let's sort that out. So reference pink is clipping. Let's have a look at Y. So I'll take you back to the desk and check out what's going on with that. I suppose this is all still part of verification. Okay, so go to the top of the block. Is it just clipping on the way in? It's a bit hot. The other thing we could do... Oh, that's better now. That's better. The other thing you could do, of course, as well is attenuate the direct out, but you go to routing, go direct out. Ah, there you go. It's plus 10, that's why. Okay, fixed up. Very good. Next, back to Smart. And onwards. Okay, so if you hit V, it clears the averager as long as you're selected on Smart. Okay, I'm going to switch delay tracking off for a moment. Boom. And next, we're going to capture a trace for the main system first of all. So I'm going to go quiet. Okay, I have captured the main, and I'm doing this on the 4th of May, 0405, enter. Okay, so the main can stay there, and then what we're going to do now is capture the sub. So we'll run the sub live over the top of the main. So momentarily I'll clear the main off the screen, just hiding the main trace that I just took. Here comes the sub. Switch the main back on. So at this point, in the handover region, we have a mismatch around 100 Hertz. So 100 Hertz isn't arriving at the same time on both the main and the subs. In fact, I'm going to capture this trace momentarily. I don't normally capture the sub trace, I just tend to leave it live over the main, but I'll capture this so we can have a sensible conversation without the rumble. Okay, now let's check the shot. Sure you can see what I hope you're seeing. Alright, just sharpen that out a little bit. So you can switch off the live trace. You can drop the impulse response as well by coming here, click live IR. Just for now, you don't need to see that. Okay, so wow, the colour's not great. So if you double click, well, go to info, change the colour to something what's going to really contrast well. I think that. How's that? Right, you can see that, hopefully. Okay, so what we're doing is we're looking in this handover region, and one thing we've got to bear in mind here is there's a lot of handover between the sub. So we seem to have a lot of handover in level between the sub and the main system, but what you've got to bear in mind in this room is the sub is really close to the measurement microphone, which has pushed the level up. It's effectively pushed the level of the sub up, even though actually they're both zeroed out on the amplifier. So the system is, as it would be from the manufacturer, reset. Zero trim, if you will, on the main and the sub. Any road, it appears like there's a lot of handover because watch what happens with the crossover when you drive the level of the sub. What I'm going to do is I'm just going to reduce the level of the sub on the main, on the fader on the desk, on the sub matrix. So I'll run it live again. We'll hide this trace, original trace. There's the sub. Sub's in green now. Okay, so reducing the level of the sub, press V. You can arguably manipulate the handover of the sub depending on how loud it is. Just turned it up a little bit. So what I'm saying is, by the way, I don't know whether you got those level offsets, but what I'd done with the fader was I'd just literally gone. I went from about there to there. So that was the picture you were seeing changing there on Smart. So crossover is level dependent, absolutely. So when we're thinking about sub handover and what frequencies we want to get properly phase aligned around, it's around a key frequency, but there's some bandwidth around that. We need to look at this handover region, but the handover region in this room is a little bit OTT because the level of the sub is up relative to the mains, but that's because the measurement mic is so close to the sub relative to the mains. It's somewhere within this region here. I mean, you can see that in the manufacturer's spec. Go and look at TI385. Search that on Moodle. It's the technical information document that D&B provide us with, and it shows crossover, handover regions, anechoic handover regions for the different loudspeaker series, mains and subs. Obviously this is with reflections. In fact, just before we actually get put the delay in, we see this cut here, 121 Hertz. Now, let's just move the measurement microphone. I'm going to move it, and then I'll show you on the camera where I moved it to, because I'll leave you watching the screen. See if that is a cancellation and see if it moves as I move the measurement microphone around. Measurement mic is in the same place as it was just before, last time you saw it. Now I'm going to move it around a little bit. So we want to hide this. No, we'll leave this trace open, and then we'll run live. Just see if it moves. Hitting V to change the averager. I moved it. Okay. So where I moved it from and to then. Right. Here's where it was before. It was on this cross here. There's where it is now. And the cancellation's moved. So is that a cancellation to do with the floor and the ceiling? No, because we didn't change the distance of the of the mic on the stand. It's a underarm bowling technique, this one. It's a ground plane measurement I'm taking. So it's not the floor. So it's something to do with the walls. That's what's causing the cancellation. How interesting is... Well, I mean, it's interesting. It's not actually going to be significant for what we're doing right now with the phase alignment. It's not affecting the time. The time that we're going to put in is going to be a time that's only our best effort at this point with this amount of time to do this actual activity in the real world. The thing is, yeah, we are time aligning around a single measurement point in this case and putting a particular time in, but that time is not going to work for everyone in the venue anyway, right? What we discussed in class is that we do this 1/3 of the way up the venue approximately as a starting point, because we're trying to find a position that's got a good representation of the rest of the venue. This particular measurement spot right now, not a great representation of the rest of the venue, but it's the room that we're working in, and it'll do for this demonstration. And so, we're going to clear off the live trace. No, we're not. We're going to leave it live. I'm going to put the measurement mic back where it was originally, exactly where it was. Okay. And that is that. Okay, so I'm going to run the sub in real time, and I'm going to apply a delay on the desk. Now, I already know approximately what it's going to be. According to what it said on the spreadsheet, the difference distance is about 13 milliseconds. So we'll start with that first, just to show you where that is on the desk, where I'm going to actually hit apply here. I'm just going to switch it on, right? I'm going to dial it in and then switch it on. There is already a delay in here already of 15 milliseconds. So that's going to knock that down to 13 as a starting point. Notice at the moment, really, it's just to do with time. It's just a delay in time. It's kind of, in that regard, it's similar to what you do with time alignment. It's just that we're looking at, we're sort of zooming in within broadband time arrival here. We're zooming in to a particular frequency, and I'm going to look at, let's say, 100 hertz, right? That's where we're going to put the crosshairs. Well, 90 to 100 hertz. We'll see how it pans out now in smart. Okay, so the delay is not in at first, so everything is as it was before when we captured the orange trace. We're not actually going to look at the orange trace because we don't need to look at the capture. We can look at the real time, but we'll compare it to the original purple one. So here comes the sub. No delay, as was originally. And we're looking around, we're going to look at 99 hertz, we think. Okay, I'm going to switch the delay in on the console. So, see it so you know where it is. You can't see smart at the same time though, so I'll fix that up in a sec. Okay, delay coming in. That was worth recomposing that shot just for that, wasn't it? And here we go. So, I'll do this a few times and switch the delay in and out, and you can see the lines move. Okay, so I'm going to put my mouse back at 99 hertz-ish. There you go. Okay, delay out. Okay, delay in. So we're headed in the correct direction, and we're just going to push that a little further. So I'm going... actually, you watch smart. I'll call out the numbers. So I've got 14 now. 14 milliseconds. 15 milliseconds. Okay. So, I'm just going to... we'll take a capture, and then I'll stop the sub so I can concentrate on what I'm saying. Okay, so I've muted the sub. And I'll switch off the live trace. So, in conclusion, what did we do? We applied this time delay to make the sub and the mains arrive at exactly the same time around a key frequency. The reason for the slanted down, we end these lines slanting down, we end up in a much more detailed conversation than the scope of this short recap. They are phase tracers. They would be sinusoidal, i.e. like that, but they're wrapped phase traces, so it's only showing you 180 degrees positive and then 180 degrees negative. Don't worry too much about it for if you're just getting used to smart. Actually, just roll your crosshair over it and notice that it gives you a readout. And the readout for the purple is going to be the same readout as the one for the green at around this point, because they're one on top of each other. And if you change over by going here, and change over to the sorry, I'm saying green. It's now blue. So the blue is I've just realised. Sorry, folks. I've called it the delay here. Of course, that's not what I wanted to call it originally, was it? It's the sub. We're not editing this video, because if this was a class in real time, I would have said the same thing, wouldn't I? So you can. Did anyone notice? At least I noticed before I got to the uploading the video, right? So. Sub 2, okay? So it's the sub that we're measuring, not a delay fill here. So this is, you can see it's late, isn't it? So the blue one versus the purple one, and the point is that if you hover the crosshair over the blue one, it's going to give you a very similar readout to the purple one. I mean, they're one on top of each other. You've got, so we'll stick with our 97 hertz. 97 hertz is negative 160 degrees through its cycle. Flick to the main. So that was from the subwoofer, 90 degrees is negative 160 degrees through its cycle. And from the main system, 97, 6 hertz, is 163 degrees through its cycle. That again, that's what you're looking at. You're looking at that frequency coming from the main system is that far through its relative cycle, measured in this case 180 degrees, positive or negative. Whereas the subs are, well, almost the same. 97 hertz from the sub is 160 degrees through its cycle. That's the point. They are that frequency is arriving at the same time. It doesn't mean that all these other frequencies are going to arrive at the same time. This is going to drop out for different frequencies. Integers are okay, others are not necessarily. Also, this red one here, this is coherence. This goes beyond this videotape, but for now, we'll just say that if this is high, that's typically a decent sign, okay? So high coherence, that's called coherence, that red thing. All right then, there's your recap. Oh, just one more thing to say. It is possible to get these phase tracers to appear to line up because it's relative phase, okay? So it's not an absolute time. You could have a time of arrival difference, but there appear to be a good phase relationship between this key frequency. Now, you could get that somehow. You could put in, let's say, 3 milliseconds, and they could happenstance to show a good lineup, a similar one on top of each other for the purple and the blue. Because you can get phase alignment, but not have that correct in terms of time difference if you look at the real thing in the real venue, which was the reason why in the first place we measured this with the laser measure, because without the laser measure we didn't get much perspective about how far away these two things really were. Remember, that is the goal, really. We're just trying to make these two objects that are both producing 97 hertz appear to be the same distance away from the listener, to try and improve really we're minimizing we're making the PA system more transparent, less obvious to the listener. Because when you listen to someone go up some notes on bass guitar, as that goes from the sub to the main flown PA system, that sound shouldn't change. But if there was a arrival difference between the subs and the main, that might seem like an obvious change. So more advanced consideration than this video, but essentially just be aware you could be out of time but in phase. So make sure that you're in time by using this thing, the cheaper one.